In the last video we have seen what is the necessity of having different data structures in any programming language. Then we have seen what are the various collection data structures that are offered by Python programming language. In this video we will see more about the list data structure, that is how do we create lists, then how do we apply various operators on list data structure. In addition to that, we will also see what are the various methods that can be applied on lists for processing the elements of the list. So, we will start our discussion with an understanding of what a list is. List is basically an ordered collection of elements, that is there is an ordering among the elements of the list. So, you can exactly say this is the first element, this is the second element, this is the third element, so on and so forth till the last element. So, because of that reason lists come under the category of sequential data structures as the ordering among the elements is preserved. Moreover, list is also a kind of compound data structure. In a list we are allowed to have numerical data types like integers, floating point numbers, even the characters. In addition to that, we can even have the complex numbers, strings, or even other complex data types like a list also. So, we can even have a list as a part of the list. Moreover, lists are mutable data structures. So, the reason is once we create the list, we are allowed to alter the elements of the list data structure. That is, we can add new elements, we can delete elements, we can update the existing elements. Because of that reason, lists are known as the mutable data structures. Now, let us see how do we create lists. We can create an empty data structure using one of these two ways, whereas a non-empty list can be created by enclosing the list of elements in a square brackets by separating each element using a comma. So, that is how we can create a list, a non-empty list and an empty list. Here you can see various types of lists. So, the first one is a list with all the elements as integers, then you can observe a list with all the elements as floating point numbers, even you can create a list with all the elements as strings also. Moreover, you can create an heterogeneous list. The first three types of lists are homogeneous as all the elements are of the same type. You can even create a heterogeneous list where the elements are of different types. If you observe the last example, so there we have a collection of strings, then an integer, a floating point number, etc. So, that is how you can create homogeneous list or a heterogeneous list. Now, let us see how do we create nested list. A nested list is basically the list which has another list as an element. That is, a list is allowed to have a list as an element. If you observe this example, so 60, 70, the last element is a list. Even then it is having a collection of elements that is treated as a single element in the list L1. We have seen so far how do we create various types of lists: homogeneous list, heterogeneous list, the nested list. Now, let us see once the list is created how to access the elements from the list. So, let us consider we have a list L1. To access the entire list L1, we can access the entire list with its name L1. Wherever you want to use the list, you can use the name L1. Whenever you want to use a single item, a specific element from the list, then you can use the index operator, that is the rectangular brackets, by passing the index to that. Say for example, here L1 of 0, it indicates that you are accessing the first element, that is with the index 0 from the list L1. Then even you can access a specific portion of the list, that is multiple elements of the list can also be accessed with the help of the slicing operator. You can have this example. The statement L1 of 4:10:2 allows you to access the elements from the indices 4 to 9 with a step counter of 2, that is every alternate element you can access from the list with a specified range. That is how a slicing operator can be used to access multiple elements from the list. Now, let us see what are the operations that can be applied on lists. So, these are the various operators that can be used on a list. We have already seen the index operator and the slicing operator to access a single element or multiple elements from the list. Then plus is the operator which is used to basically concatenate multiple lists and to get a single list. Asterisk is the operator which is used to repeat a specific list for n number of times. Then in is the operator that allows to know the membership of an element. It tells us whether the element is present in the list or not. Now let us see how do we use various operators on list with examples. So here you can see L1 of 5. So that retrieves the element at the index 5, that is 50 is retrieved. So here in this example I am trying to access a portion of the list with the help of the slicing operator. When I say L1 of colon 5, it allows us to retrieve all the elements up to the index 4. So here is an example which shows us to concatenate two lists and then it returns a single list. That is how the plus operator can be used to concatenate multiple lists. Now let us see how an asterisk operator is used to repeat the same list 4 times. So here a list is having a single element, a string Vignan, and because we are using the asterisk operator with 4, the same list is repeated 4 times and it is returned as a single list. If you observe this membership operator in, so here 10 in L1, that statement returns true because the element 10 is available in the list L1. So basically this membership operator returns either a true value or a false value depending on whether the element is existing in the list or not. If the element is existing, then it returns a true, otherwise it returns a false value. That is how we can use all these operators on the list to perform various operations. So we have already discussed that lists are mutable. So why they are known as mutable data structures? So you can alter the elements of the list data structure after its creation. That is, it is possible to add new elements. Even at the end you can add, at the middle you can add, at any specific index you can add new elements to the list. So that is how they are mutable. Even you can replace a specific element or multiple elements of the list. It is also possible to delete an existing element from the list. So because you are allowed to alter a list, it is known as the mutable data structure. Now let us see how do we use various methods to process the list elements. So first we will see how to append an element to the existing list. The general form is to append with an element. So append is the method which takes a single argument and whatever the element you are passing, that element will be appended at the end of the list. So here you can observe the example when you are appending 40 to the list L1, it will be added at the end of the list L1. In this case, we are allowed to append only one element to the list using the append method. But is there any way to append multiple elements to the list? Of course, yes. Extend is the method which allows us to append multiple elements to the list at the end. So extend is the method which actually takes an iterable as an argument and allows us to append multiple elements to the end of the list. If you observe this example, L1 dot extend of a list. You are passing a list of elements, that is 100 comma 200 to the extend method as an argument. Then as a result 100 comma 200 are appended to the list at the end of the list L1. That is how either you can add a single element by using the append method or you can even add multiple elements to the end of the list using this extend method. Now let us see how do we insert a new element to the list. Insert method is the one which allows us to insert a specific element at a specific index. You need to pass two arguments to the insert method, the index and the element. What is the element you want to insert and at which index you want to insert this particular element. So consider this example here, I am inserting the element 100 at the index 2 to the list L1. As a result 100 is the element that is inserted at the index 2. Now let us see how do we remove an element from the list. It is possible to remove a particular element from the list using the remove method which takes a single element as an argument. If you observe this example, I am removing the element 10 from the list L1. L1 dot remove of 10, it removes the element 10 from the list L1 and returns all the remaining elements in the list. So remove is the method which allows us to remove a particular element. Then is there a way to remove an element at a specific index? So of course we have. So pop is the method which allows us to remove an element from the list at a particular index. So here you can observe this example. So which allows us to remove an element from the index 0. So when you apply L1 dot pop of 0, it removes the element at index 0, that is the first element from the list L1 and returns that list. And moreover, you can even use pop method without passing any index. When you use the pop method without any arguments, then the last element of the list is removed, so that it can be used as a pop operation from the list basically. So, it would be better if we have any method that supports us to clear all the elements from the list. So, clear is the method which allows us to remove all the elements from the list, that is, it just removes the entire list of elements that are available in the list when it is called with a list. Here you can see the example L1 dot clear, it clears the entire list L1, all the elements are removed, but remember the elements of the list are removed, the structure of the list L1 remains available for us. So, you can access L1 as it is. So far we have seen how do we alter the list, how do we append elements into the list, how do we remove elements from the list, even how do we insert new elements into the list. Then now let us see how do we update the elements in the list. We can use the slicing operator or even the index operator to either update a single element or to update multiple elements of the list. Whenever you want to update a single element, use the index operator. Whenever you would like to update multiple elements, you can use a slicing operator to update the multiple elements. So, here if you observe this example L1 of 0 equal to 100. I am using the index operator to update the element at the index 0 with the value 100. Moreover, slicing operator can be used to update multiple elements of a list L1 of 0 colon 2. So, here we are allowed to update the elements at the index 0 and 1 with the elements 100 and 200. So, as a result what happens is the elements of the list L1 at the positions 0 and 1 would be updated with the values 100 and 200. So far in this lecture we have seen how lists are known as the mutable data structures, how to apply various operations on the list to alter the existing list, kind of how do you add the new elements, how to remove the elements, how to update an existing element, or even how to clear the entire list of elements. So, that is what we have seen in this lecture. In the next lecture, we will see how built-in methods can be applied on a given list. Thank you for watching this video.